first what we're going to do is we're going to do numbers 2 and 3 together. Make sure that you are, even though you already have answers written down, make sure that you are still looking over this and following along. If you need to erase, which some of you will, you may not have had to erase if you'd actually taken my advice and done all the steps and figured out what each piece of the problem meant. Because once you figure out what each piece of the problem means, you know what the remainder means. If you know what the remainder means, you can answer these questions. Okay, number 2. We're going to read it once. Every period, we're going to stop and visualize. I think some of you still aren't doing that, so it makes me feel like all this extra, me modeling it, it's just me taking energy that I don't have to take if nobody's going to listen to it. So number 2, Gianna is at the school carnival. Okay, I'm imagining a girl standing in the middle of what looks like fall festival. She has 58 tickets. Okay, I'm imagining her with a handful of tickets. I'm not imagining 58 individual tickets. I'm just imagining like maybe 2 handfuls of tickets or a bag full of tickets that she can take around. Because 58's a pretty big number. It costs 3 tickets to play the basketball game. I imagine her in front of like a basketball, like one of those things where it has a basketball net and like a board behind it, and then there's a kind of like fabric underneath where the ball comes back to you. It's tilted, and I'm imagining that it has a sign on it that says 3 tickets. So she needs to have, out of those 58 tickets, she's going to need 3 tickets each time she wants to play. She's going to have to take a group of 3 tickets, give it to the person each time she wants to play. If she plays the basketball game as many times as she can, how many tickets will she have left? So I'm imagining she's got all 58 of those tickets. She doesn't want to play anything else. She's practicing her basketball shot. So she's just going to give groups of 3 tickets to the guy who's in charge of that game until she either has none left or she doesn't have enough tickets left. So she's just going to keep giving that man 3 tickets until she has 2 or less tickets left over. Okay, so that's what's happening in this problem. Now I'm going to go and find my important pieces of information. First thing is my question. What's the question? Carla.
How many tickets will she have left?
How many tickets will she have left? I can find what in that question? Colin.
Our answer unit.
Our answer unit. How do I find my answer unit?
You look after how many?
I look after how many, which is what?
Tickets.
Tickets. The noun after how many is my answer unit. In this case, tickets. I now know the unit for which part of my division problem. Now that I know my answer unit, I know the unit for which part of my division problem. If you guys had remembered to label, you would remember this. We talked about this. You can even look back at number 1 if you followed along with me and you put you labeled, because you'll see the answer unit underlined with AU above if you did that on your own, which some of you still refuse to do, and by showing what we labeled the quotient as if you did that, which some of you still refuse to do. Victoria? We know the unit for our quotient. So Victoria, what will the unit for our quotient be? Tickets. Now, does that include the remainder? Not necessarily. Could be, but it just depends on which part is. Our remainder unit depends on what other part of the division problem? Our remainder unit depends on what other part of the division problem? Aaron? Our dividend. How did you know that? I can't hear you. I can't hear you. Okay, you looked at the guided practice and noticed what?
The remainder is people left over and dividend is the people.
Okay, how else? So Erin knows because she looked at the number 1 on the guided practice and she noticed that the dividend unit was people and the remainder unit was people left over. How else would you know that? Zadie?
Because it says in your notes.
Okay, what does it say? I know it says it in your notes, but I want to know what it says.
The remainder of the dividend will always have the same unit.
The remainder and the dividend will always have the same unit. Come on, guys. This is the 3rd day. Okay, so now we know what the quotient unit is. We don't know the remainder yet because in order to know the remainder unit, we need to know the dividend unit. Well, let's figure out the dividend unit. Let's go back to the beginning. Gianna is at the school carnival. That just sets the scene. That doesn't tell me anything about what I need to solve. She has 58 tickets. Well, I see my answer unit, tickets, and I see a number before it. So that means 58 tickets will be important. Then the next sentence. It costs 3 tickets to play the basketball game. I see my answer unit tickets again with a number before it. So that means that's important too. But I found my 1 unit 3 times. Does that mean I don't have another unit? Does that mean I don't have another unit? I found the same unit tickets 3 times. Does that mean that's my only unit? Zari?
No.
No. Why? How do I know? I don't see another noun yet. So what does that mean?
It's just telling us the things we so far need for our problem.
Okay, well, how do I know that that's not my only unit? How do I know that tickets is not my only unit?
Because it's not the only noun.
How do I know that tickets cannot be my only unit? Does that mean school carnival's a noun? So does that mean that's a unit? Is every single noun a unit? Gianna's a noun. So it has nothing to do with nouns. How do we know that tickets cannot be my only unit? Zadie?
Because it says in our notes that in the dividend divisor and quotient, no remainder, 2 will have the same unit and 1 will have a different.
Not quite. Victoria?
It says in our notes, in a division problem, there will be 2 units.
Louder, please, so everybody can hear.
In a division problem, there will be 2 units.
In a division problem, there will be 2 units. I feel like some of you just might as well just throw that away. It's just getting in the way because you're not using it at all. Some of you probably, it doesn't even look like you still have it, which I told you not to lose it. So if you don't have it anymore, we're not going to take the time for you to redo it. So, sorry. Because in your notes it says, for a division problem, there will be 2 units. We know 1 is tickets. We need another one. Well, what is it? If she plays the basketball game as many times as she can, how many tickets will she have left? I see something that I did wrong because maybe it doesn't always tell us this. This says how many tickets will she have left? 58 divided by 3. 58 tickets, the total number of tickets she starts with, divided by 3 tickets, the number of tickets in each group, will not tell us how many tickets she has left. So how many tickets she has left will be the remainder. So what is that other unit? We know 58 tickets is the total she starts with. 3 is how many is in each group, how many it costs to play a game. So what is the unit for the groups? We need 3 tickets for each one. Smith.
For each game.
So what's our other unit?
Games.
Games. Does the problem tell us how many games there are? So what is games the unit for? Victoria? The quotient. Remember, the quotient is what we don't know. So that means if we have a unit with no number before it, that unit is the unit for what? If we have a unit, we have tickets and games, but we don't see any numbers before that unit, that means that unit is the unit for what part of our equation? Cullen?
The quotient.
The quotient. So now we know 58 represents what? 58 represents what? Carla?
We know 58 means the tickets.
The total tickets. The tickets she starts with, which means our remainder, if we have one, will represent what? Colin?
How many tickets are left over?
Tickets left over. Because the remainder represents the amount of the dividend that is left over. We already know the quotient is games. What does this 3 represent? Sorry. What does the 3 represent? It's more than just tickets. Smith?
How many tickets are going into each group?
So, tickets per game, or the number of tickets, the number of items in each group. The games are a group. We're splitting the number of games, and we're putting 3 tickets in each one until we get to what? We're putting 3 tickets in each group until we get to what? Carla.
We put only 3s into groups until we have 1 or 2. But
Okay,
we
nope.
don't know.
Zari, we put 3 tickets in each group, 3 items in each group, 3 tickets per game until we get to what?
58
or
close.
something close to it. Because are we always going to be able to put exactly 3 tickets in each group? No. So we're putting 3 tickets, 3 items in each group, 3 tickets per game until we get to 58 or something close to it. So now we know what each piece means. Yes, that took a little time, but which one would you rather do? Take a little time and get it all right? Or go as fast as you can and get like an F? Class.
Take time.
Take time. Okay, because some of you, I can already tell, if you don't take time and you do what you've done the past couple days, when this homework gets graded, it's not going to be good for you, because that will go into Power School. Okay, Zari, now we need to solve. We know what each piece means, so we're ready to solve. Okay, step 1, we divide the tens, which means we see how many times what will go into what?
3 would go into 5.
Okay, and how many times will 3 go into 5?
1.
Once. So we're going to line it up with that 5. Next, we multiply, which means we multiply the digit we just got by our divisor. So what are we multiplying, Ethan? Aaron, what are we multiplying? Can't hear you.
We're multiplying 3 times 1.
The digit we just got, 1 times 3, which is what, Aaron? The digit we just got, 1 times our divisor 3, which is what? 3. Where do we put it? Up here? Above the 8? Under the 8? Under the 3? Under the 5? Now we subtract. We subtract the answer to our multiplication problem from the first digit of our dividend. Carla, what are we subtracting? Just tell me. You don't have to say a bunch of words. Just tell me what we're subtracting.
5 minus 7. 3.
5 minus 3, which is what?
2.
2. So we line that all up. Victoria, next we bring down. Where do we go to find something to bring down? We go to the dividend. Do we bring down this 5? How do we know? There's a number underneath it. What about this 8? We bring it down because there's not a number or an arrow. So we're going to go ahead and put an arrow, and then bring it down. What do we now know, Victoria? We know our new dividend. Our new dividend is what, Victoria? 28. Okay. Now we're ready to divide again. So Mason, we're seeing how many times our divisor will go into our new dividend, which means what? We're trying to see how many times what will go into what? Tell me the actual numbers. We're trying to see how many times our divisor will go into our new dividend. What's our divisor? What's our new dividend? How many times will 3 go into 28 without going over? 9 times. So we line that up with the ones place because we know we're in the ones place now. Okay, Smith, now we multiply. What are we multiplying? Tell me the words, not the numbers.
We multiply our divisor by the digit we just got.
Okay, we multiply our divisor by the digit we just got, which means we're multiplying what?
3 times 9.
3 times 9. And what is 3 times 9, Smith?
27.
27. So we're going to line that up with our new dividend. And we're going to do what now, Smith? Colin?
We're going to subtract 28 minus 27.
28 minus 27, which equals what?
1.
1. Now we need to check for what, Zadie? Can't hear you.
You need to check for
Michaela, what do we need to check for?
we need to check to see if there's a number. If we don't have a number.
So we need to check for something to do what with? Something to bring down. Where do we look? But where? This is all our division problem. In our dividend. How do we know if we're ready, if we have something to bring down, Zadie? If we have something to bring down, what will it look like?
It will look like there's nothing under.
There's no what? What things?
There's not a number or an arrow.
There's not a number or an arrow. What about this 5?
That has
What about this 8?
an arrow.
Is there any other digit? So do we have anything to bring down? So what are we ready to do? Compare, which means we have to say the answer to our subtraction problem is what?
Smaller than or 5.
Less than our divisor. Is 1 less than 3?
Yeah.
So what does that mean about this 1?
That is our
It's our remainder. Okay, so now we know 58 divided by 3 is what, class?
19 remainder 1.
19 remainder 1. Okay, now we have to figure out, does that answer our question? Can I say there are 19 remainder 1 tickets left? Is it possible to have remainder 1 tickets? Can I go up to somebody selling tickets at a school at Fall Festival and say, hi, can I have 19 remainder 1 tickets? And they're like, what? And you're like, oh, excuse me, can I have remainder 1 tickets? Is that possible? No, so we have to figure out, okay, what is the answer? How many tickets will she have left? Well, we know she started with how many tickets? Michaela, 58. How many tickets did it cost to play the basketball game? Zari?
3.
3. How many games did she play? How many times did she play the game? Smith?
19 times.
19 times. We know the answer to the quotient was games. How many games were there? She gave that man that was running the booth 3 tickets 19 times. How many tickets did she have left over? Michaela, 1, because we know the remainder is the tickets left over. So, Michaela, please read this last sentence and fill in the blank loudly so we can all hear.
So there is 1 ticket left.
So there is 1 ticket left because we know she started with 58 tickets. Each game cost 3 tickets. She played the game 19 times. There was 1 ticket left over. Okay, some of you are just letting the fact that there's a lot of words get in the way of knowing how to solve it. You guys know how to read. You can comprehend what you read. Bless you. Don't freak out just because now we have numbers and reading together. It's the same exact thing. It's the same exact thing. There's just numbers, but it doesn't change reading comprehension and how reading comprehension works. Figure out what you know. Figure out what you need to know. But once you name each unit, it makes it a lot easier because we can say what it is at the end. Okay, whoops. Number 3. We're going to read it through once, visualizing, imagining what it looks like. Then we're going to read it through again, finding the important pieces of information. Remember, we're going to stop at each period and we're going to picture it. If you can't picture it, go back and read it again until you can. Okay, number 3. There are 75 people waiting in line to ride a roller coaster. Okay, I'm imagining I'm at Six Flags. We're in line for a roller coaster. There's 75 people. Now that's a lot of people, so I'm not going to count each person in my brain, but I am going to imagine a really big group of people. And they're all in line. They're wrapping around. You know, there's like those bars so that you line up kind of like a snake so that more people can fit in a smaller area. Okay, I've got that. They're waiting. Each car of the roller coaster holds 6 people. Okay? So I'm imagining a roller coaster car, and I'm imagining 6 spots. Like I'm imagining that it goes upside down, so I see those like shoulder harnesses. I see 6 of them in one car. Not the whole roller coaster, but in one car, one little piece. I'm imagining 6 of those shoulder harnesses. Okay? How many cars will be needed? That means I need to figure out not how many of the shoulder harnesses, but how many of the groups of shoulder harnesses. Okay. So now let's go through and let's find the important information. Well, first, what is the question, Kingston?
How many cars will be needed?
How many cars will be needed? Okay, what do we know just by looking at that question? Michaela.
We know that
What do we know just by looking at the question? After we find the question, what's the first thing we've always looked for ever since we did subtraction and addition word problems? Our answer unit. What is the answer unit? Cars. Now, we learned in the question before, is the answer unit always the quotient? No. Sometimes it's the quotient, but sometimes it's what part? Like in number 2. It was what part? The answer unit fit with what part? There's only 4 parts to a division problem. Aaron? Not the dividend. I mean, yeah, but that was just coincidence. But there's 2 parts of a division problem that actually tell us our answer, what we don't know when we start out. What are the 2 parts that tell us our answer to a division problem, no matter whether it's a real world problem or not? Carla, what are the 2 parts to a division problem that tell us our answer?
The dividend and the
Not the
remainder.
dividend. We're told the dividend, otherwise we don't have a division problem. Victoria? The quotient and the remainder. So now we know, in a division word problem, is the answer unit always the quotient? Come on, guys, think. Some of you are just like, this, I don't get it, so I'm done. Well, good luck on your homework. Just because you don't get it doesn't mean you can't. It just means you don't in the moment. But that's the whole point of school. So some of you, I can tell, you're going to really struggle tonight. You're going to get really upset. Your parents are going to get upset. It's because you're just staring off right now and you're not even trying anymore. And that's exactly what it is. Some of you are still ignoring me, and it's really frustrating. You're going to struggle tonight if you continue to ignore me. You're going to. I can't be in your brain forcing you to listen to me. I can't. It's not possible. But just know, if you choose to ignore me and say, this is too hard, I don't get it, I'm done, you will struggle tonight. That's all I can say. And now it's your choice to listen or to ignore. It's your choice. I can't make that. Can I make that choice for you? Can I make the choice for each of you to pay attention and get what I'm trying to tell you? Can I make that choice for any of you? I can only make that choice for myself. I can't, you have to do it yourself. Victoria, the answer unit does not always tell us our quotient. If it doesn't tell us our quotient, what part will it tell us? The remainder. So, should we say yet that cars will 100% be our quotient? Victoria?
No.
No, because it could be a remainder. Maybe it could be both. I don't know. Let's find out. Okay, let's go back to the beginning. There are 75 people waiting in line to ride a roller coaster. Well, I see a number in people. Do I know 100% yet if people is one of my units? Let's list our units. What do I know is my unit so far? What do I know so far is definitely one of my units? Carla.
People.
Do I know that for sure? Smith.
No.
What do I know is 100% one of my units?
Cars.
Cars. Smith. Carla, please make sure you're listening right now. Smith, why do you know that cars is definitely one of my unit, but you don't know that people is yet?
Because we found cars after how many?
So we already know our unit, our answer unit. So that means cars has to be one of our units. Have we found anything yet that tells us people is one of our units? Smith?
No.
No. Can we probably say it's probably going to be our other unit?
Yes.
Can we say maybe yes, but can we say 100% yes yet, Smith?
No.
No, we have to keep reading to find out if it is. It probably is, but let's not put it down until we're sure. Like that time where we had lines and entrances. We needed to figure out which one exactly did they mean. Did they mean how many entrances? Which would just mean 5. Bless you. Or how many people in each line. We have to figure that out. Okay, so we know 75 people is probably going to be important, so let's keep it in our mind. Let's not forget about it, but let's keep reading to make sure it's important. Each car of the roller coaster holds 6 people. Oh, well, I see each, which tells me what? Smith.
We're doing multiplication or division.
Multiplication or division. Aaron, I see the word car after each. Does that tell me my other unit yet? No. But what do I know about each car, Aaron? What do I know about each car?
We know that
I visualized it. If you visualized it with me.
we know that each car holds 6 people.
We know each one holds 6 people. So that means we now know what's our other unit? People. Because if we look at all the nouns, line. Do we know how many lines? Are we worried about lines after we read this problem, Aaron? No. And the other nouns are cars and people. We know cars is important because it's our answer unit. We know people has to be important because we're trying to figure out something with people. We have 75 people and we have 6 people. So we know there is a total of what? A total of what? By looking at this problem, we know there is a total of what? We cannot get bigger than what number? Cullen?
75.
75. If we can't get bigger than a number we know we have, does that mean we're doing multiplication or division? We can't go any bigger than a number we know.
We're doing division.
We're doing division, because if we did multiplication, we'd end up with a number bigger than 75. If we started with 75 people, will we ever end up with more than 75 people? Will we ever end up with more than 75 cars? No. Because if that would mean that we'd have to put one in each car and then still find extra people somewhere. But are there extra people? And do we only put one person in each car? No. How many people do we put in each car? Michaela? 6. Okay. So that means my larger number is 75. I'm putting them into groups of what? I have 75 people. I'm putting them into groups of what? Zadie? 6. So I know I'm taking 75 people and I'm dividing it into groups of 6. So let's look at our equation. 75 represents what unit? 75 represents what unit? Mason? People. 6 represents what? Aaron? More than that, people in each group or in each car, because we know the cars are our groups, right? We're putting things inside the cars. The items are what we put inside the group. So we're putting people inside the cars. That means people are the items, the cars are the groups. Are we putting cars inside the people? Are we putting people inside the people? No. We're putting people inside the cars. People are our items, cars are our groups. So, like Aaron said, 6 is the people in each car. Items in a group. Which means our answer has to be the number of items in each group or the number of groups. If our divisor tells us the items in each group, is our answer going to be the items in each group or the number of groups? Zari?
The items in each group.
But our quotient is the items in each, our divisor is the items in each group. Can our quotient and our divisor be the same thing? Can I take 6 items and put them in 6 more items? No. So that means if our divisor is the number of items in each group, our quotient has to be the number of what? Come on, guys. There's only one option. We know each piece of a division problem means the total number of items, which is what? Total number of items is what part of the division problem? Smith.
The dividend.
The dividend. Does that ever change, Smith?
No.
No. The dividend always, always, always is the total number of items. The remainder is always, always, always what? Zadie?
The number of left over.
The items left over. The remainder is always, always, always the items left over. The dividend is always, always, always the total number of items. Now sometimes the divisor and the quotient switch. Sometimes the divisor or the quotient, there are 2 things the divisor or the quotient could be. They are either, that means they can't be the same thing. They are either the items in each group or the number of groups. In this case, we know the items in each group, the people in each car, which means the quotient has to be the what? It's the only other option. It's either one or the other. We already have one, so that means it has to be the other. So it's the number of, Cullen? Smith?
Cars.
Well, the number of, if we had, just for any problem, no matter what, it would be the number of, if the divisor is already the items in each group, the answer is, the quotient is the number of
Groups.
groups. Come on, guys, it has to be one or the other. They can't both be the same thing. You can't have a divisor that's groups and an answer or a quotient that's groups. It doesn't work. It'd be like taking baskets and saying, I have baskets and I want to divide them into groups of baskets. Can you do that? No, because they're all going to stay in the same group, right? If you're dividing baskets into groups of baskets, how are you going to choose? They're all baskets, right? You can't say, I want to put 5 items in each, you can't say I want to put 5 apples in each apple. Can you do that? No. So in division, one part, when you're looking at the quotient and the divisor, one part has to be the items in each group, which means the other part is the number of groups. Does the dividend ever change? It's always the what? Come on, guys, you have it. Don't be scared. The dividend is always the what? Carla.
The number of something.
The total number of items. Always. Does the dividend ever change, class? The dividend always represents what? Kingston. The total number of items. Class, does the dividend ever change? No. It always represents what? Zadie.
The total number of items.
Class, does the dividend ever change?
No.
It always represents what? Smith.
The total number of items.
The total number of items. Class, does the remainder ever change?
Yes.
Class, does the remainder ever change?
No.
No. What does it always represent? Michaela. The items left over. Class, does the remainder ever change?
No.
What does it always represent? Mason. The items left over. Class, does the remainder ever change? What does it always represent? Victoria. The items left over. Class, does the remainder ever change?
No.
What does it always represent? Zari.
The leftovers.
The items left over. Please don't try to change the vocab because then that confuses people. It shouldn't, but it does. Do you see why I'm having to repeat this over and over and over again? You're not listening to it the first time. Sometimes not the second time. So maybe the third or fourth time you will. What about the divisor? Does it ever change? Carla.
No.
Colin.
Yes.
Okay, what does it change between? Because now I know, you know it couldn't be no because of my reaction to what Carla said. So now, how does the divisor change? What does it sometimes represent? Okay, so now I know you only said no, yes because you knew it wasn't no. Mason, what does the divisor sometimes represent? Not a 0. Never represents 0. We can't divide anything into 0 groups. Smith, what does the divisor sometimes represent? Think of those 4 parts. Total number of items, items left over, items in each group, groups, those are the 4 parts. We know the dividend always represents the total number of items, so there's one thing down. We know the remainder always represents the items left over, so there's another thing down. We have 2 left. Sometimes the divisor can be one of them, which is what, Smith?
The items in each group.
The items in each group, which leaves only one option. Sometimes the divisor can be the what? It's the last thing left. Smith?
The total number of groups.
The number of groups. But the quotient and the divisor sometimes switch. 1 means the items in each group. If 1 is the items in each group, what is the other one? Aaron? Is it the total number of items? Is it the items left over? So what's the only other thing left? The groups. Come on, guys. You have to think about that, okay? We're going to have to spend another day on this because That's why it's taking us so long, because you're all not thinking. You're either just ignoring me or you're thinking, I have no idea. I can't think of what it is. Yes, you can. You just have to stop thinking, I can't, and start thinking, stop. I know there's only 4 things. I know there's only 4 things it can be. There's 4 parts: dividend, divisor, quotient, remainder. Those are the 4 parts. They can only represent 4 things. Item in each group, groups, total items, items left over. Okay, there's 4 parts to a division problem. There's 4 things they can represent. That means each one has to match. Okay, I got that. I know the dividend never changes. It always represents the total number of items. And I know the remainder never changes. It always represents the items left over. I know the divisor and the quotient can switch, but they can't be the same thing. One has to be the items in each group. One has to be the number of groups, and sometimes they switch. But they can't ever be the same. My dividend and my divisor and my quotient can't ever both be groups, and they can't ever both be items in each group. I know this problem tells me there's 6 people in each car. That sounds the same. 6 people in each car sounds the same as 6 items in each group. So that means my divisor has to be the items in each group, people in each car, which means my dividend has to be the number of groups. Well, the groups in this problem, what I'm putting items into is a car. So that means my quotient unit has to be what? Carla?
Cars.
Cars. Which means my remainder, if I have one, has to be what? I'm just going to say the dividend quotient and add leftover. I'm sorry, the dividend unit and add the words leftover. What's the dividend unit, class?
People.
If I add the words leftover, that means my remainder represents what, class?
People left over.
People left over. Okay, now I know what each piece means, so I'm ready to solve. Step 1, Kingston, 6 fits into 7. How many times? Once. Zari, 1 times 6 is what?
6.
Cullen, 7 minus 6 is what?
1.
Carla, what am I bringing down?
I'm bringing down the answer to the.
Okay, Carla, just tell me, what am I bringing down?
You're bringing down the 5.
I'm bringing down the 5. So what's my new dividend?
50.
15. 15. I know that you know what number. Just make sure you're saying it. 15. Remember, 50 looks like this. Mason, how many times will 6 go into 15? 2 times. Zadie, 2 times 6 is what?
12.
Victoria, 15 minus 12 is what? 3. Zadie, do I have anything left to bring down? Is 3 less than 6?
Yes.
So what is 3?
Our
Our remainder. So class, 75 divided by 6 is what?
12 remainder.
12 remainder 3.
How many cars will be needed? Is it 12 remainder 3, class?
No.
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 Okay, now let's look. This is where, remember I said, if your remainder is people and your quotient is groups, do you leave people out and say, sorry, you can't fit? What do? what do you do with the groups? Do you say, nope, sorry, 12 cars full, you can't get on? Victoria. You just you add another group. So we have how many full roller coaster cars? Zari.
12.
12. And do we say, sorry, 3 more people, you can't get on until you find 3 friends? We can only have full roller coaster cars here. No, we just add 1 more car. Does it have to be full? No, because in real life, are they going to say you can't get on because this roller coaster car isn't full? No. I mean, there are some rides that are like that, but most rides are not. They're just like, okay, yeah, here you go. You get a half-empty car. You get more room. So, is the answer to how many cars will be needed 12 cars? Kingston? Is the answer 12 cars? No. Why? Why is the answer not 12 cars? Aaron?
The remainder is 3. And that's not, there's 3 people left over. So if we wanted to look at the whole number, we'd have to add the remainder to, right?
That would be 15. Do we need 15 cars? 12 full cars and then 3 extra cars with 1 person in each one? Are we ever adding the remainder? Are we ever adding the remainder? No, it never says add the remainder because there's only 3 people. Each car fits 6. Are we going to add 3 more cars? No, we're only going to add how many more cars? 1. Because those 3 people can go in 1 car, right? There's just empty spaces. So it's not 12 cars because then we say, see ya, 3 people, you can't get on. Sorry, find friends. I guess you're just a loser. Can we say that? No, is that true? No, we're just going to say, okay, 12 full cars. Here, you last 3 people, get on an extra car. How many cars is that? Is that 15 cars? No, because we're only adding 1 more car, which is Zadie, how many cars?
13.
So, they will need
13.
13 cars because, everybody listen, we're going to add a note to this. When people are left over and the quotient shows the number of groups, the answer is the next whole number. Now that's just when you're imagining a number line. What is the next whole number after 12? What is the next whole number after 12? Is it 3? Does 3 come after 12? Is it 1? Does 1 come after 12? What is the next whole number after 12? What number comes next? Cullen?
13.
13. So when people are left over, that means your remainder is people left over, and your quotient is groups. That means you're putting people inside of that thing. The answer is the next whole number, which in this case is 13. Okay, we're going to do more of this tomorrow, which means your homework tonight is number 4 and 5. The quicker you guys can really think about this and stop just trying to rush through it, then that means we don't have to keep doing more and more days of this. But if you guys continue to just rush through it and get done and not understand anything at all, you're just trying to get done, well, can we move on if you don't understand? No, because then what's going to happen when you get to the test or the check my progress, which is what comes next? What's going to happen if I just let you say, oh, you don't understand, you're not willing to put the work into it to understand, let's just move on to the check my progress. What's going to happen on the check my progress, Zadie?
You're not going to know what to do.
You're not going to know what to do. You're going to get it wrong. You're going to think you maybe know what to do. You're going to guess. You're just going to rush through it. You're going to get it wrong. And then what's going to happen when you get to the test? Victoria, you're not going to know what to do. You're going to get a bad grade. And then what's going to happen when you get to the Iowa test or whatever testing we do this year? Zari,
We won't know what to do.
you won't know what to do. And if you don't know what